Good morning, my name is Kate Swafford, and today I'm going to be talking about the vulnerabilities in physical systems, specifically pertaining to the programmable logic controllers. So first we're going to talk about the theory behind PLCs, starting with the birth of the first PLC at GM in 1968, and then we're going to go into modern-day PLCs and how they work. And then we're going to go into the logic behind PLCs and how that can be exploited. So first, the birth of PLCs, like I said, they were designed at GM in 1968, and this is Dick Morley, pictured with the first PLC, and he is considered the father of PLCs. And it's because engineers in the Hydromatic division at GM wanted to replace relays with a more stable and capable option, so they designed PLCs with the intention that they are easily maintained, they're expandable, and they are capable of all the logic functions necessary to act on a physical system. So modern day PLCs, AMCI makes them, and they describe the process in 4 steps. So the first would be that the PLC does an input scan to find out what kind of inputs they're getting. It can be motion sensors, it can be buttons. So there are a lot of different ways that inputs can be given, and then those are converted to bits and bytes, which are processed by the program scan part, which is the second part. And so in the program scan, it goes into the CPU, and it takes the instructions out of the ROM and puts them in the RAM, so that it can manipulate the data that's being sent from the input to the data it needs for the output scan, which is the third part. And so the output could be motors, it could be alarms, depending on what the physical system is doing. So the program scan, the second part, is essential, and so this is where all the logic resides, because for example, if it is a voltage reader as an input scan, if it hits, let's say, 10 volts, and an alarm is supposed to go off, the program scan has to read in the 10 volts and then know that, oh, 10 volts is too much, and so then trigger the alarm on the output. And the fourth part is called housekeeping, which is communication between the terminals. So logic in modern day PLCs, there's a lot of different logic languages, but these are 2 common ones. So one is ladder logic. So it's set up similarly to how the physical system is actually set up. So you can see the pumps and the switches and the starts. And then there's also instruction logic, which is more like assembly language. So it's going to say load, and then a register, and then reset. So it's set up more like assembly language. And the logic portion of the PLC, so the second part of the AMCI step, the program scan, is where the exploitation, this exploitation is happening. It's because if someone can manipulate the logic that the PLC uses to send outputs, and they can manipulate the way the system is receiving feedback. And that could be disastrous for the system. In one of the examples that is under the exploitation part of this presentation, you will see how it destroyed 984 Iranian centrifuges, and that was because of a PLC attack. So exploitation, we're going to talk about Stuxnet, which is a very well-known PLC attack, and then embedded devices. Unfortunately, I cannot demonstrate the embedded devices being affected by this exploitation because I do not have an elevator with me or embedded devices that I can use, but I will talk about how the project we did in SY202 last year can be really easily exploited. So Stuxnet was a worm that was introduced to the plant physically, and it took over 984 Iranian centrifuges, and it was able to do that because, and it was able to go undetected for that long because it was affecting the PLCs. So the PLC would read in a certain speed that the centrifuges were spinning, and it was supposed to send alarms out if it was spinning too fast. But the worm manipulated the way the PLC logic worked, and so the centrifuges were spinning too fast, but the PLC was reporting back that it was spinning at the right speed, so no alarms were going off, and the scientists had no idea there was anything wrong, until it had already destroyed 984 of their machines. So the exploitation that anyone in this class could do would be, in SY202 we created an elevator and we programmed it using an embedded device. And so the embed that we used was programmed using C++ in MATLAB. And when we compiled that program, it was compiled into machine code and then it was sent to the embed. And so the embed would take in a user inputted height, so in inches, and then it would read a motion sensor to see how high the elevator was and determine, and using the logic that we sent it, so the PLC logic, it determined which way the motor, the DC motor should spin and how fast the DC motor should spin. So it would send an output in RPMs to the DC motor. So an easy way to exploit that would be to just change the way that the motion sensor was determining what height it was at. So instead of the motion sensor reading 14 inches, it would read 4 inches when it was actually supposed to be at 14. So the motion sensor is at 4 inches, it would read 14 inches, and so if you actually send it to 4 inches by the user, it would slam into the ground because it's not at 14 inches, it's at 4 inches. And so it would destroy the system, and so this is a very easily exploited hack. So for risk mitigation, I would propose patches that would require PLCs to authenticate users before they could before they could change the logic. And I would also recommend non-repudiation, so even if authenticated users change the logic, it would still alert admins that the logic has been changed, because hackers could always use an authenticated account to manipulate the PLCs. The policy implementation would be that there would be a weekly check or a weekly maintenance on the PLCs to determine if any of the logic in the program scan had been changed or manipulated, and so if it was manipulated, then to get it back to the original logic that it's supposed to be. And so the main risk mitigation here is just use Sienna. You need authentication and non-repudiation in order to ensure cybersecurity, and so those are just basic principles that should be also implemented with PLCs. So the solution would be cyber security, and so since we are the cybernauts, it's our job to implement that. So thank you guys for watching.